Let's start off circle day. Circle day. Triangles and parallelograms day one. Rhombus, trapezoid yesterday. And then today, circles. And then we got this new vocabulary term to talk about what a sector is. All right, not a scepter like the kings hold or whoever holds, right? Sector. Area of a circle. Hook me up real quick. Area of a circle. Look back if you need to. 1, George, hello. Pi r squared. How you doing today? Good. I'm doing well too. Thanks for asking. You kids. All right, ready? Example 1. I didn't want to do a simple one, right? Find the area. That's cute. How about I give you the area? Can you help me find the radius? All right. Area is pi r squared, right? Where's the 95 going? Where's your 95 going? 14. Where's your 95 going? Area, and we're solving for radius. All right, I just want to see what you guys can do to this. All right, what you can do to this. 12, first move to solve for the radius. Yeah, divide both sides by pi. Everyone's probably getting a number on the calculator. What am I going to ask you not do? Don't, you guys are good. Don't round it. Now look, if you don't want to write the full thing on your paper, you can write all the numbers out, or you can just write 95 over pi. It's up to you. All right, or that long decimal they have, but I just don't want you to round it. And then what's my final step here to solve for the radius? Oh, 6, little help. There you go, square root of both sides. So take that number in your calculator. Hopefully you haven't cleared it out. Take the square root of it. And I know you're not going to be happy with me, but tough beans. I did this on purpose. Anybody see any rounding directions? If you don't see any rounding directions on the Regents exam, we got to write it all out. Okay, so I just wanted to expose that to you that, hey, no rounding directions. We got to write it all out. This is the only time I'll have you do it, but I just wanted to let you guys know that Regents rule. Square centimeters or just centimeters? Square them or no? No, because it's not area. It's a radius length. Good. All right, all good? All right, now to this new vocabulary term called a sector. Basically, think of it this way. Draw in 2 radii, and then the arc that connects them. See all this in between? That's called a sector. Oh, it's like a piece of pizza or a piece of pie. Yeah, sure. You can think of it that way. Okay, that's exactly what it is. Okay, sector. All right, the area inside is the sector. All right, so how do we find it? Just like this whole unit, a bunch of formulas, right? So if your angle is in degrees, your central angle is in degrees, you're going to see the formula I give you looks a little familiar. The first half of it anyway. Let's see if anybody remembers where it's from. Measure of the arc over 360. I'm going to stop there. Anybody remember from last unit? That was the start of what formula as well? Oh boy. Come on, somebody dig deep. Measure of the arc over 360 was the same way we started the formula for come on. Don't even want to take a shot. Was the formula for arc length? Yes, it was the formula for arc length. And then anybody remember how we finished it? Times pi d, the circumference. That's how we finished it, right? Pi d. But now, since we're going inside the circle, we're going to finish it by multiplying it by pi r squared, which is the area. Yeah, radius. Thank you. Radius squared. The area of the circle. Good. Ooh, we got a problem though, Cal. We got a problem. You guys just learned this year. Is there another way to measure an angle other than degrees? Yeah, it could be in what, unfortunately? Radians, and that formula is useless if it's in radians. So the formula to use if it's in radians and not in degrees, it's really not that bad. 1/2 r, which is squared. So I take 1/2 my radius squared, and then I multiply that by, ooh, anybody remember our friend here, what we call this one? Theta? No, anybody? Theta, good, good, theta. That right there, theta, that's your angle in radians, all right? So whatever the angle in radians is, that's where I plug it in. So that's how I find the area of a sector if I'm given the angle in radians instead. All right, ready to use everything now? We ready, George?
Yeah.
Yeah. You got any big plans this weekend?
No.
No? Corner bureau? Balled up?
Yeah.
Wondering what it's like to have friends?
Yeah.
It's all good. We've all been there. We've all been there. All right. What's the area of the sector? Radius of 8, angle of 60. What's your angle in? What's my angle in? Radians or degrees? Degrees. So I'm going to use the degree formula. The area equals measure, and I don't need to see this every time. Measure of the arc over 360 times area, pi r squared. All right, help me fill it out. What is the measure of the arc in this case? If my central angle is 60, my arc measure is 6. If my central angle is 60, what's the measure of the arc? Also 60. They're equal from last unit, remember? 60 over 360 times pi. The radius is already given as 8 squared. Whoa, whoa, whoa. Before you start clicking on the calcs, notice the multiple choices. They're all in terms of what? Pi. Yeah, so if you put pi in your calculator, you're not going to see this at all. So leave the pi out. Everyone leave the pi out. And let's do 60 over 360 times 8 squared. And if you're still getting at a decimal, hit your math button and change it back to a fraction. But we should not be plugging in pi. So I notice all the answers are in terms of pi, so I leave it out of my calculation. And what fraction are you getting here now? When you're ready, 12?
32.
Yep, 32 over 3 pi. Good work. Basic sector, right? Basic. Find the area. All right, this is probably one of my top 10 questions of the year right here. We had 4 students, 4 geometry AB students. They think they're hot stuff. So they decided they're going to calculate the area of sector COB. And you don't need to color it in, but here you go. COB, this bad boy right there, right? We're going to find that area. So they came up with 4 different calculations. 2 of them are right, 2 of them are wrong. Who's the embarrassing ones? Okay? That's what we got to figure out. Who's wrong, who's right. Hey, let's do our own period 4 calculation right now. How would we do this one if I found the area of sector COB? So the first thing I would do was measure over 360. So what is the measure of the arc here? 1. Hi, George. 108. So it would be 108 over 360 times pi. What goes next? Your radius. Do you guys have options? Give me I know none of them are labeled, but give me a radius in this diagram that could be plugged in. George? AO, yep. Mm-hmm. I could do AO squared. What are some other options if I didn't want to do AO? What else could be plugged in there? Hey, 14. What else could be plugged in there? OC. Anything else could be plugged in there? 7. OB. All right, so we got some options. That's how period 4 would do it. Let's go through all the what?
You want us to say half?
No, I don't. All right, everyone good. Those are our options. So, okay, let's go through these 4. Amy. She did 310 times pi times BC squared. Do you like it or no? Do we like Amy's or no? If you're going to say no, which is correct, Amy's incorrect, but why? 4.
She's incorrect because BC isn't in the
Darn right. She's using BC, and that's a chord, not a radius. Embarrassing. I don't know. Did anybody have an issue with the 3/10 is fine? Anybody know why? The 3/10 isn't the issue. Why? That's just 108 over 360 reduced. So that's fine. It was the BC part. Beth. Maybe short for Bethany. Elizabeth. Maybe. Anybody know a Bethany? I had a student Bethany years ago. No? You know Bethany, Cal?
I don't.
All right, Bethany, right?
Elizabeth.
No, Bethany.
Oh, not
I know. I know a ton of. A ton of Elizabeths. Yeah. I'm asking for Bethany. Bethany. Okay. Who knows? Good or no?
Yes.
I hope so. It matches ours. All right. It matches one we came. 108 over 360 times OC squared. Beth can stay in class. Carl. How's Carl doing? Carlos? Probably not. Short for anything else? Carlton? Carla? So it might be a woman. Okay. He, she, right or wrong? Well, let's see. 3/10 is fine. Pi. Is it okay? Is it okay they did 1/2 of AB? Because what is AB? Diameter. You take half of it, you get a radius. Way to go, Carl. And then we bring the Dex. Definitely Dexter. Definitely. I don't think anybody just full name is Dex. Gotta be Dexter. Gotta be. We know he's wrong, or she, but why? What are they squaring? Are they squaring a radius? No, they're squaring a diameter, right? That's on the outside of the 1/2. That's the difference between Carl and Dex. Carl's squaring half the diameter, while Dex is just squaring the diameter. Embarrassing. So our 2 winners here, Beth and Carl. Great little problem there. Great problem. You guys all good? All right, last thing I want to do before we get nuts is what if I give you the area of a sector, but I want like the angle or the radius instead on this side? All right, so that's what we got to just cover before we get crazy. All right, everyone see the area of this. I'm giving you the area of the sector is 12 pi. You know the sector area. What's the angle? AOC. AOC, what's the angle? I'll start you guys out. Sector formula. Measure over 360 times pi r squared. You tell me where everything should go now. There's your sector formula. All right, let's start. Where's the 12 pi going here? Oh, 18, 12 pi. Area, 12 pi equals, what are you plugging in for the measure? 15? X, yep, because we're trying to find the angle. X over 360 times pi. What are you plugging in for your radius? 13? 6. Here we go. How do I get X by itself? Well, first, what do you see on the left and the right that whether it be step 1 or step 4 are going to cancel out on both sides eventually? Pi's are going to be gone. So why don't we just make our lives easier, get those out of there. 12 equals x over 360 times, and I'll just clean that up, 36. All right, algebra studs, what's your next move? Or what do you want your next move? Because you could do one of two moves now. One of two moves would be correct here to get x by itself. Let me hear what you're thinking. 5, Jackson, what are we thinking here? To either get rid of 360 or get rid of 36. I don't care. Okay, how? Multiply both sides by my 360. Multiply 12 by 360 as well. Could you have divided by 36? Yeah, you could have. We would have got to the same result. That's a large number, huh, everybody? 4,320. 36x. I won't call in anybody next because I'm assuming you guys know what the deal is. $120, right? For angle AOC, $120. So we are comfortable solving for this side now. All right, because I could ask you to solve for the angle or the radius now. All right. All right, ready to get nuts before the weekend? We've gone through 3 different days of figures. Now what I'm going to do, I'm going to take 2 of those figures, smush them together. What's the total area? All right, so smush them together. What's the total area, as you can see by our patio question here on number 5? Oh, here we go. Just going to be lighting kids up now. 16. How's this figure? What's this figure made up of? Good. 19. Okay, hold on. So ready? This is made up of a trapezoid plus what's on the bottom? Half circle, semicircle. Everyone agree? Half circle. We're all in agreement. Formula time now. Look back in your notes if you need to. Formula time. Area of a trapezoid. Let's go. 5. Jackson, area of a trapezoid. 1/2.
1/2 height, and then
B1, B2, good work. Plus half of a circle, which we went over today, was 4. Good. So now it's on you guys now to fill in the correct numbers. And I believe everything you need is already on the diagram. You're welcome. All right, who's going to help me with the trapezoid? Trapezoid help, please. 15. Height.
4,
Base, one of the bases.
10,
Other base.
7,
Make sure you add them, everybody. 10 and 7. Plus 1/2 pi. Anybody got a radius for this semicircle? 12.
25.
Good. There you go. Wasn't too bad. Luke, was that too bad?
That's not too bad.
And darn right it wasn't. Luke, I got another question for you, even though your number didn't come up. And if it's too personal, let me know. How long are we going to go with that lettuce on the top of your head? Yeah. Do you usually have it that long? Is that just a preference? Yeah. Lettuce, yes, you're on your hair.
yes.
You usually?
Yeah.
It doesn't like get in the way, or
Not really.
you don't get hot? Really? Okay. On average, how many woodland animals sleep there during the night?
6.3.
Okay. Because that's the other drawback. You cut it, some couple animals are going to lose their home, right? That's the drawback.
Put some condos in
Don't even get going on the hair there. Like, I don't know when they came out with it. I don't know if it was yesterday or maybe the 1700s, a comb, but I don't know. Or right before you leave home every day, you're like, light socket, then leave. But everyone gets a piece. Everyone gets a piece. All right. All good? All right. Ladies, don't worry. I don't even touch your hair. Don't even worry. I won't say a word. You do you. $73.3. All good? Questions? All right. One more before I let you go on your own here. Did I say leave it to the new? Yeah, 100th. Nice. All right, this one's a little bit trickier because I just don't give you all the values and plug them in. This one here, it's a rhombus. They tell us it's a rhombus plus what's around the rhombus? What's around the rhombus here? 8. What's around my rhombus here?
Semicircle.
How many?
3.
Which would make a total of 1.5 circles, right? Everyone agrees? 1.5 circles? Formula time for me, please. Formula time. Rhombus formula? 14. Rhombus formula.
Half of the diameter times.
What?
The diagonal.
Thank you.
The diagonal of it times the
Good. I already asked this. No reason to ask it again. 1/2 pi r squared for the circles. Read through the problem because one of those figures is a lot easier to find the area of than the other. Do I know anything about the diagonals of the rhombus? Here we go. George, what do you know about the diagonals?
they're equal.
No, they're not. I'm sorry. Read the first sentence of the problem. It's fine. It's fine.
Diagonals in the figure 24 and 10.
So I could just 24 and 10. Yep. There you go. And they're never equal, by the way. Okay, FYI, for future reference. What about the, wait a second. The radius of one, first of all, this isn't the radius, that's the what? That's going to be the diameter. So when I do find it with your help, I'm going to have to cut it in half. The question is, how do I find that then? So I can cut it in half. Well, if you remember, I think it was yesterday, we did properties of a rhombus. They're perpendicular and they bisect each other, right? So that 24 and 10 gets split up into 12s and 5s. Agreed? Now can you find that third side? How are you going to find that third side? 6. Pythag, yep. So off to the side, 5 squared plus 12 squared. So what are you finding that third side, aka the diameter, is 13?
13.
Hey, look at that. Yep, 13. Make sure we cut it in half though, right? Make sure we cut it in half because that's a diameter of the circle. So we're going to plug in 6.5 here, not 13. And then you guys are rounding to the nearest 100th, huh? Just check my work too here. Ooh, 0.09, but the 9 rounds. So what are we going to do? 1.0, yeah. I got 0.098 at the end. No? Yes, no? So the 8 rounds that to a 0, which rounds that to a 1. Right? That's how they taught it back in the day, I believe. Any questions? All right, I'm going to start you on this one and you're going to finish it for me. Okay, I'm going to start it and you're going to finish it. Now it's find the area of this shaded region. Okay, find the area of the shaded region. Yes?
We don't have that.
You don't? Oh, maybe I put it in the homework then. We're done? We're done, huh? Or maybe I had it. Oh, I had it for you on Monday, I believe. All right, if we're done then, you only have 4 questions out of your packet. All right, work with people around you on it. Check your answer key before you pack up. Check your answer key before you pack up. It's fine with me. We don't have that.